Woohoo! Welcome back. Tonight we're going to be talking about functions. Now, functions are a collection of correspondences. Basically, anytime you connect one set to another set, you can look to see whether that connection is a function. The way we're going to see it for the most part in this class is it's going to look like equations that have x and y in them. And we're mostly just going to be looking at them and saying, is this a function? Is it not a function? The reason we're interested in this is that functions turn out to be a lot easier to work with. And so we're going to spend this section discussing what's a function, what's not a function, and what can you do with them. So to get started with this, we've got a couple of vocabulary words. Sorry about that. The first one is the independent variable. Now, when you've got a function that is connecting variables together, the variable that you begin with, or the input, is considered the independent variable. And this will usually be x for us, although it doesn't have to be. The dependent variable is the variable that depends on the independent variable, or the output. For our class, this will usually be y. And a function is a relation, a correspondence between two sets. So in this case, it's a lot of times it's going to be x and y, so that each input, each x, corresponds to exactly one output. So to discuss it, I'm going to discuss some real-world examples of relationships that might or might not be functions. So the first one is a correspondence between a person and their birthday. Now, if you define your birthday as the day when you were born, the official day listed on your birth certificate, for example, or the moment when you were born according to the people who were around when you were born, everybody has one of these. So, if you look at a person and you look at their birthday, each person has one birthday. So this is a function. Now, it is possible that we could have a conversation and say, well, what about situations where, for whatever reason, your birthday is wrong? Or that in some cultures, you may celebrate two birthdays. There may be your official birthday and then another day that's also celebrated, like the beginning of the year, or a day that corresponds to other things that were happening. In that case, this would not be a function. So this is a situation where it depends on your definitions. And that's going to happen a lot in math as well. It's going to depend on exactly what our definitions are to tell us whether or not we have a function. The next correspondence would be the correspondence between a person and their eye color. And depending on who you are and what your eyes look like, I think a lot of people would say, oh, sure, this is a function. Because if you look at a given person, then you could correspond with, say, brown eyes. Or another person might have blue eyes. But in fact, there are some people who have more than one color. One eye would be brown, one eye would be blue, one eye is green, one eye is blue, etc., etc. And so in this case, when there's the possibility even of one person who has two different colors, this is not a function. So basically, a function comes down to the idea that if you ask a question, it's usually easiest to work with if you get one answer. So what about the correspondence between a person and their pet? Is this a function or not a function? And the answer is, and I don't know if you could hear it in the background, but I have multiple pets. So even if nobody else has multiple pets, the fact that I own more than one animal means that this is not a function, because any given person, like me, might correspond with a cat to a cat and another cat. And in fact, I've run out of room, but then we could also put in a rabbit. So this is not a function. Because here the question, or the person we start with, could correspond with multiple answers. And that's not going to be acceptable. Another way we can look at functions is to draw a picture using something called a Venn diagram. And this is going to be a special kind of Venn diagram that I'm going to use. I will start off, and rather than discussing what the sets are, I'm just going to say this is set A and this is set B. And one of the easiest correspondences is if set A corresponds with set B very simply like that. One element of A corresponds to one element of B, and this is a function. Nice and well defined and not complicated. Okay. Then, if we have a set A and a set B, it can get very complicated. They don't have to go straight across. I could draw the arrows all crossing each other like that. And if we take a look at it, is this relation or correspondence, is this a function? And the answer is yeah, this is. Okay, this is getting exciting. I know, I can hear it. You're all like, ooh, this is so exciting. Is there more? And the answer is yes. Wait, there is more. What if I have a situation where every single one of the elements of set A correspond to a single element of B? Now, this can be confusing because a lot of people say, whoa, 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 this is a lot more complicated. But it turns out that this is actually okay. This is called a constant function. This means that your answer to every question is the same. So if I ask you, no matter what I ask you, you give me the same answer. For example, the way I think of this one is this is the DMV. If you have to go into the DMV and you've been standing in line and they say, okay, once you get up to this point, now you've got to go to the next window. If they send everyone to the same window, everyone goes to window 5, that would be this example. That is a function. Now, what happens if you're at the DMV and they say, okay, but you're going to need to go to this window and at the same time, you're going to go to that window? The answer is you can't go to both windows. You have to pick one. And so this is an example of not a function. We don't really have a good word for that other than just saying this is not a function. This is a correspondence, this is a relationship, but this is not a function. And in fact, it doesn't matter even if you try to make it better by like saying, okay, well, we can make the rest of them behave. These other two elements, they correspond just to this last element, so everything's fine. But the problem is that if you do have the one element that corresponds to more than one, so one question, more than one answer, then you have something that is not a function. Okay, woohoo. So